Hello, this is the video number 5 of the Cisco CCNA course, Chapter 5, Ethernet. Ethernet is the most widely used LAN technology. It operates in the data link layer and the physical layer. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. It supports data bandwidths from 10 MB per second to 100 GB per second. Ethernet standards define Layer 2 protocols and Layer 1 technologies. It relies on the two separate sublayers of the data link layer to operate. First, Logical Link Control (LLC) and the MAC sublayers.
In graphical context, these are our OSI 7 layers, and the Ethernet network belongs to the data link and the physical layer.
The Logical Link Control (LLC) is a handles communication between upper and lower layers. It takes the network protocol data and adds control information to help deliver the packet to destination. It is implemented in software, and its implementation is independent of the hardware. The MAC constitutes the lower sublayer of the data link layer. It is implemented by hardware, typically in the computer NIC. It has two primary responsibilities. First, data encapsulation. Second, media access control. Data encapsulation includes frame assembly for transmission and frame disassembly upon reception of a frame. Additionally, the MAC layer adds a header and trailer to the network layer PDU, Protocol Data Unit. This operation provides three primary functions. First, frame delimiting. It identifies a group of bits that make up a frame, also provides synchronization between the transmitting and receiving nodes. Second, addressing. Each Ethernet header added in the frame contains the physical address that enables a frame to be delivered to a destination node. Third, error detection. Each Ethernet frame contains a trailer with a cyclic redundancy check, CRC, of the frame content. Media access control. It is responsible for the placement and the removal of frames on the media. This layer also communicates directly with the physical layer. If multiple devices on a single medium attempt to forward data simultaneously, the data will collide, resulting in corrupted or unusable data. Ethernet provides a method for controlling how the nodes share access through the use of a Carrier Sense Multiple Access (CSMA) technology. Carrier Sense Multiple Access (CSMA) process. It is used to first detect if the media is carrying a signal. Then, if no carrier signal is detected, the device transmits its data. If two devices transmit at the same time, it's called a data collision. There are two commonly used methods. CSMA, collision detection. The device monitors the media for the presence of a data signal. If a data signal is absent, indicating that the media is free, the device transmits the data. If signals are detected, showing that another device was transmitting at the same time, all devices stop sending and try again later. While Ethernet networks are designed with a CSMA CD technology, with today's intermediate devices collisions do not occur. Wireless connections in a LAN environment still have to take collisions into account. Another method is the CSMA collision avoidance. The device examines the media for the presence of a data signal. If the media is free, the device sends a notification across the media of its intent to use it. Then it sends the data. This is used by 802.11 wireless networking technologies. MAC address, Ethernet identity. The MAC address was created to identify the actual source and destination nodes within an Ethernet network. This is a 48-bit binary value, expressed as 12 hexadecimal digits. It is the result of IEEE enforced rules for vendors to ensure globally unique addresses for each Ethernet device. There are two principal rules for the vendors. First, they must use the vendor's assigned OUI, organizationally unique identifier, as the first 3 bytes. Second, all MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes.
Created using parte1.1.